Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right up there. I'm not sure how I'm going to title this, but I'm going to tell it how I title it in the title. But what I am sure of is our one goal for the day. And our first and only goal is to solve one-step equations using addition or subtraction, and we're going to check our answers. So let me clarify what solving means. Solving means to isolate what is asked for. So we're going to get the variable, which is the letter by itself, on one side of the equal sign. Checking means we plug in our answer and simplify completely. If we get a true statement, we have a solution. If we get a false statement, there is a mistake. All right, and I'll go over some situations for both scenarios. And here's a tip, since we're doing addition and subtraction. I want you to think of a positive number like having money, and a negative number is like owing money. And we've got a guest in this room, a cricket that doesn't want to stop cricketing. I've tried to find it, but I can't. Okay, so we have 6 problems. There's actually 2 more variations that aren't on the board, but I think that we can figure them out based on what this will be about. And so the directions are solve for the variable, which means get the letter by itself on the equal sign, and then check, which means we plug in our answer and simplify completely. These are one-step problems, okay? And we need to isolate what is asked for. And so on problem 1, I want x by itself, and x is not by itself because of this plus 2. And I need to make plus 2 go away. So in order to make plus 2 go away, I'm going to subtract 2 to both sides. All right, and I'm doing the opposite of what I have with the variable. And what that does is it cancels out the number and it isolates the variable on one side of the equal sign. Now let's think about having money and owing money. There's no negative sign in front of this 8, so it's considered a positive 8. If I have $8, I spend 2 because I owe 2. That means that I'm left with $6. I've isolated x and I've got my answer. Now let's check. Alright, so everywhere I have an x in the original equation, I'm going to replace it with a 6. So my original equation was x plus 2 equals 8. I'm going to replace the x with a 6. So x now turns into a 6 because they're interchangeable. Now notice I haven't simplified completely. I can still put these together. 6 and 2, that gets me to 8. 8 equals 8. That's true. I have a true statement, which means that I have a solution. So this is good. X equals 6 is the answer to that equation. All right, moving on to the second example. Now, the second example is a little different than the first example in that the order of the numbers, the variables switched. The idea is still the same. I want to get x by itself, but I have a positive 3 keeping that from happening. So since this 3 is positive, I have to do the opposite like I did with the 2 to get the variable by itself. So what I'm going to do is I'm going to subtract 3 to both sides. And again, I'm using the number that's on the same side as a variable. Some people like to draw a line so it's a little bit more clear who they need to get to the other side. These 3's cancel each other out. The x comes down automatically. X equals, I have 7, I owe 3. That means that I have $4 left over, right? Positive, take away because it's a negative. I have a positive left because I had more to begin with than what I owed. All right, let's check this. So it would be a good idea if you tried to do some of these on your own instead of just watching me work through. This will help you get a little bit better at this. All right, so I'm going to rewrite the original equation. You don't have to rewrite the original equation. I'm just doing that to really reinforce where x is going and how to plug it in. So everywhere I have an x, it turns into a 4. So now I have 3 plus 4, and that equals 7. Well, I haven't simplified completely because I can add these together. So I have 3, I have 4, that means that I have 7, and 7 equals 7 is a true statement. So that means that x equals 4 is a solution to this equation. It makes it true. All right, the third problem. Let me explain the variation of the third problem. On the first two problems, the x was on the left side. On this problem, the x is on the right side. I hope I said left side. The x is on the right side. The idea is still the same. We have to figure out who we have to move away from the x to get the x by itself. And I have to move away a plus 5. So I'm going to do the opposite. I'm going to go minus 5. Minus 5. Okay? So these are going to cancel. And I'm left with my x on that side of the equation. I'm going to make a mistake on purpose. And then I'll show you what a false looks like and then how we deal with it. Alright, so I'm just going to make a common mistake. I'm going to say that minus 9 minus 5 is minus 4. And so now what I'm going to do is I'm going to check. Okay. So here we go. Minus 9 equals, and they're working hard outside. Hopefully that doesn't interfere too much with this lesson. So minus 9 equals, everywhere I have an x becomes a negative 4. I haven't simplified completely. I owe 4, I have 5, that means I have 1 left over. And that's false. There's a mistake here. Alright, I said I was going to make a mistake, and the mistake that I made was right here. These two numbers together is not negative 4. Think about it like money. If I owe you $9 and then I owe you 5 more, you're going to tell me that I owe you 14. You're going to tell me that I owe you $14, not $4. Right? And so if I put in a negative 14 here, if I owe you 14, I give you 5, you're going to tell me that I still owe you $9. So this is actually now true, and I actually have the correct answer. So again, if you check and you get a false statement, you made a mistake, and this is a way that we can hopefully go back and find it. All right, so all three of these problems are all solved by subtraction. These all solved by subtraction. Okay, that's what it looks like to solve by subtraction. Let's look at the remaining three here. X minus 6 equals 10. So I'm going to draw a little line to show who is keeping x from being by itself. I want to isolate the x, and so in order to do that, I'm going to add the 6 to both sides. Those cancel out. X is equal to, I have 10, I have 6, I have 16. So let me check here real quick. So again, I'll write the original equation, and then I'll plug in my answer. Well, x equals 10. Okay, I can still make a 10 out of that. There we go. So everywhere I have an x is going to turn into my value. Again, I have not finished simplifying completely. I can put these together. I have 16. I paid off 6 of that. I owe 6 of it. I get 10 equals to 10, and that is true. All right. So that was what it would look like to solve by adding. Again, I'm making the number go away by doing the opposite. All right. So again, like the first two problems, the variation was the order switched between the number and the variable. Well, in this problem and this problem, the same situation. They're switched. So again, I need to get the variable by itself. The negative 4 is keeping that from happening, so I'm going to add 4 to both sides. Okay, the 4's cancel out. X is equal to, I have 12, I have 4, I have 16. Oh, another same answer. Okay, let's go ahead and check this. So again, I'll write the original equation, minus 4 plus x equals to 12. Everywhere I have an x, now it becomes a 16. Minus 4 plus 16 equals to 12. I owe you $4, I have $16. That means at the end of the day, I still have $12, and 12 equals 12. So that means that I have a solution, and x equals 16 is my solution. So I'll do that, and then for those of us that need everything to be the same, I'll do that. And I got one more problem. Now, like before, we saw what happened when the order switched. And then we saw what happened when I put the x on the other side of the equal sign. This last problem is no different. No different at all. Alright, so I want to get x by itself, but now it's on the right side, and minus 12 is keeping that from happening. So what I'm going to do is I'm going to make the minus 12 go away by adding 12 to both sides. And let's see here. That's going to cancel out. X is equal to, I owe you 10, I got 12, that means I have 2 left. So let's go ahead and check this. Alright, so I'll write my original equation one more time. Minus 10 equals x minus 12. Everywhere I have an x, it becomes a 2. So minus 10 equals 2 minus 12. 2 minus 12, I have 2, I owe you 12 bucks. You're going to tell me that I still owe you 10 bucks. Minus 10 equals minus 10. This is true. And we have another solution. This is all the math that we need to know for our first lesson. How to solve one-step equations by doing addition or subtraction. And again, I just recognize what number is with the variable on that side of the equal sign. And I pay attention to what sign that number has. And then I add or subtract the opposite. And I just want to point out one more thing. These problems we solved by addition. So this is just hopefully really reinforcing the goal. Addition, I can spell that. Alright, so I'm going to go ahead and end this here. This is the first lesson for this class. It's one-step equations. I have no doubt that we can do this. Again, have a good day, everybody. I say it for the first time, so it's the first time. Have a good day, everybody. Bye-bye.